Yanis Kaf, student number 160-5000, and this is task 1 for sensor technology. Please excuse the noise from the builders next door. So my project is using an ultrasonic sensor and 2 potentiometers to control the parameters within a max patch. The source code for this was taken from trollmaker.com, and I've made quite a few changes and I'll point them out as I'm explaining the code. The first two lines of code are for this ultrasonic sensor. We have the trigger pin, which is outputting a ultrasonic frequency, and the echo pin, which is detecting the reflection of that frequency. Then there are 2 LEDs which were added in the source code. One, I've labelled these red and green, and these are attached to pins, digital pin 11 and 10. I've also added my own, another LED, which is yellow, and that's attached to pin 9. Also, we have here 2 potentiometers on A0 and A1 of the Arduino. Here we have the pin modes, which, as you can see, the trigger pin is outputting the frequency, the echo pin is inputting the data. Effectively, the echo pin is triggered by the return of the sound wave. This part of the code here is from the original source code and is for the sensor. Effectively, what's happening here is this section is turning the trigger pin on and off, and this is effectively a pulse. It's pulsing out a frequency. The pulse in is measuring a pulse. This measures a pulse, and the pulse that it's measuring is the echo pin, and the echo pin is always enabled. And so the pulse, the duration, is the pulse that is received from the echo pin. The distance is the duration divided by 2. The reason it's divided by 2 is because the time it takes for the sound to reach the object also has to return from the object to the sensor. So the time is doubled effectively, so we have to half the time, and then again we have to divide it by 29.1. I'm not sure why it's this number exactly, but I know that by dividing it by this we're getting the distance from the object from the sensor. I'll come back to these lines of code in a moment. They're for the LEDs. So down here we have an if and an else statement. This is for the signals. So firstly we have the potentiometer values here, and the if statement stating if the value of the sensor is above 200 or below 0, then output both potentiometer values as they are, and also output 201. The original code said output out of range, which it messed a lot of things up in my max patch, so I've put 201, that way I can control it when it gets to the max patch. So if it's above 200 or below 0, output this, else output the distance plus also the potentiometer values. Going up here to the LEDs, these 3 blocks here, first it's saying if the distance is below 5, then display the red LED and turn the other 2 off. Else, if the distance is above 200 or out of range, then display the yellow LED and turn the other 2 off. Else, display the green LED and turn the other ones off. I'm just going to demonstrate this quickly. I'll have to move the camera. As you can see, the green LED here, I'm now too close, so we've got the red LED, back in range, and then out of range. In range, out of range, too close. I'll now go over to the max patch, and as you can see here, I'm still learning how this works, but what I can tell is it's taking the data from serial port B, 9600, and outputting what is the data that is being picked up by the Arduino. So here we have the sensor. This is the ultrasonic sensor, and as you can see, I've put here an if statement that's effectively the way this works is the value is taken and put into this number box. If the number is 201, then this bang will not send the number to the next message box. If it is anything else, say 10 or 11, then it will be sent to the next. This statement will allow the bang to send that to the next message box. And if it goes out of range again, you'll notice that this number stays at the last value that was recorded. You'll see here I have a step multiplier on each of these values. Sorry, these are both potentiometer 1 and 2. You'll see that I've times this one by 2.5, and then this value and this value have both been divided or times by 0.02. This is just to adjust the range of each dial. So firstly, I'll go up the 2 potentiometers are controlling parameters in the granulator. So the granular synthesizer, click here to load the sample. The sample then takes 1 second of the sample is taken and is triggered by a metronome. So that 1 second of the sample, the grain of the sample, is triggered by the metronome, and that can be adjusted right here. But that adjustment is actually being controlled by potentiometer 3. So potentiometer 3 controls the metronome amount. Also, the grain is added up with a sine wave and a saw wave, and the pitch of the saw wave is adjusted using potentiometer 2. The sensor, and this is the receive from dial 2. The sensor, the receive for dial 1, which is the sensor, is controlling the delay time. So if I move this here is a delay, and it's controlling the time of the delay. That is the end of the demonstration for Task 1 Sensor Technology.